Hey there, so tonight I want to go through how to do the second Dalton's Law worksheet. The first problem was a pretty straightforward Dalton's Law problem with the gas being collected over water. So in this problem, what you're looking at is having your total pressure equal to the pressure of your water vapor plus the pressure of the oxygen gas. You were given the total pressure to be 738.2 mmHgs, and then you were told the water vapor pressure at the 21.5 Celsius is 19.2 mmHgs, and then that would just leave you to manipulate and solve for the pressure of the oxygen. Okay. Now the second problem was a two-part problem. The first part of the problem was the gas was collected over water and you had to solve for the pressure of the dry argon gas. The water vapor pressure at 25 Celsius is 23.8 mmHgs. So the first part is you're going to be looking for the pressure total is the pressure H2O plus the pressure of the argon. So you're looking at having, and you were told it is at STP. So your total pressure for this, you were told it's at 780 mmHg. So your total pressure is 780 mmHgs. Your water vapor pressure then is 23.8 mmHgs. And that allows you to solve for the pressure of the argon. Now the second part of the problem is going to be a Boyle's Law problem. So Boyle's Law was P1V1 equals P2V2. Your P1 is what you just calculated. So if you did it right, you should have gotten 756.2 mmHgs. Your V1 is 120 mils. Your P2 is at STP, so this is going to be 760 mmHgs. And then your V2 is what you solve for. And that is how you do the second problem. Now the third problem is also a two-part. So for the third problem, first thing you need to do is establish a balanced equation, which looks like it's pretty silly, but it's necessary for this. So you have carbon dioxide solid goes to carbon dioxide gas. The first part is we need to use stoichiometry to solve for the number of moles of carbon dioxide gas. So how you're going to approach this first part is you're going to take your 7.8 grams of CO2, and that's your solid technically, and you're going to change it to moles, and then you have to change from the solid technically to the gas, and that is going to give you the moles of CO2 gas. What you're going to do then is use PV equals nRT rearranged to solve for pressure. So you're going to use P equals nRT over V. So when you substitute in to solve for P, you have 0.18 moles. And because our pressure is in mmHg or torr, whichever way you want to look at it, we're going to use the 62.4 liter mmHg per mole Kelvin. And the Kelvin temperature of this problem is 300. And then the total volume is 4 liters. So that will give you the pressure of the CO2 gas. Okay. The second part of this problem then is just using straightforward Dalton's law. So the pressure of CO2 plus the pressure of the air is going to give you the total pressure. So this pressure right here is what you just solved for. This pressure, you're told in the problem, is 740 torr. What you have to remember, a torr is an mmHg, so you don't really need to change it. And that is how you solve that problem. If you have any further problems or questions, please send an email to me. And if not, I'll talk to you later. Bye.